In this video, we'll be finishing off the drivetrain we've been working on these past two tutorials. So I have the drivetrain opened up here. You'll notice I hid some of the parts. They're not gone, but I just hid them. And if you don't remember how to hide them, you just hover your cursor over the part and then press tab, and then they'll temporarily be hidden. And if you want them back, you can click on them, click on the sideball, and they're back. But I'm going to keep them hidden for now because we're going to be doing some work on this motor plate that I forgot to do in the last video, and that is adding some holes for mounting these motors. So what we're going to do is we're going to right click this face and click edit sketch. Now we're going to get the circle tool right here, or the circle tool, and then we're going to line these up on these holes right here. We're going to drag them out, and then the radius for these holes will be 2 millimeters. For all these screw holes, there will be 2 millimeters, by the way. We'll line this up. You're just going to hover your cursor over the hole until like the little orange thing and a crosshair appears. What this is doing is it's coincidate mating the center of the circle you're creating to the center of the screw hole. And then if you want to be safe, what we're going to do is we're going to delete that coincident mate and then fix it in place. And that's because if the motor for some reason gets moved around, that hole will move with it and you might mess up your parts. So we're gonna, once we have all these holes done, we're gonna click on the center of each hole, right click, and press delete all. And then we're gonna fix these in place. Right click, delete all, fix. Get the center, right click, delete all, fix. Get the center, right click, delete all, fix. These holes. So now no matter where the motor is, the holes will stay in the place we've set for them. And yeah, so we have our holes here now, so we're able to mount this motor on. So now that that's done, we're going to unhide all the stuff we hid before. Click on it and then click the sideball. Anything else? Oh yeah, some sonic. We also have to, for these sonic hubs, since they're assemblies, you have to go all the way down here, and then you'll see these white icons. There you go. So this drive pod is pretty much finished at this point. To complete the rest of the drivetrain, we're going to have to replicate this drive pod onto the other side, and then we'll attach them using 2 low side U channels. There's a way to mirror the drive pod onto the other side, but in my opinion, I just find it more peace of mind to just recreate it, because then when I edit something, it won't affect anything else outside of it. So we're going to copy a couple parts right here. We're going to get this. I'm going to go run through this faster than I did for this tripod, because at this point, if you need help, you can go back to the other tutorial, and then that'll explain it. We'll click on this inner drive plate, copy it, Control C, and then paste it with Control V. Now what we're going to do is we're going to line these 2 plates up. We're going to get the center hole over here, or we're going to get the interior of this hole, and then you're going to get the corresponding hole on the other plate, and you're going to concentric mate these together. And then you're going to do that on the other side. There you go. So now this plate can move along the same axis and plane as this plate right here. So now that this is good, we're going to go to goboda.com and get some parts to attach these 2 plates together. So I'm going to open up my browser, click on Goboda. Okay, so we're going to go to Structure, Channel, Low Side U channel, and then we're going to select the 208 or 288 millimeter length one. Go down here, get the step file. And then we'll also we'll go back to structure. We'll click on mounts, and then we'll click on gazetted angle mounts. I don't really know how to pronounce them, but that's my attempt. And we'll click on this 1204 series gazetted angle mount. This is what we're going to be using to attach the channel to the plates. We'll grab the step file as well. And open this. Okay, so we have our channel. We're going to say no to import diagnostics. We're going to save it. We're going to call this one 11 pull low side view channel. Oh, we're going to go back here. Drivetrain. There we go. Now we're going to close out of this. We're going to head over to our gazetted angle mount file. I'm just going to call this angle bracket. Documents, Atlantis, design. There we go. Okay, so we have our parts. I'm going to close and go back to our tab over here. First, we're going to import our channels, and we're going to use those to attach these two plates together. Where is our channel? Here it is. Okay, so we're going to grab this face right here, and then we're going to get the interior face of this plate, and then coincidentate them together. And then we're going to get the opposing face right here, and then get the face of this plate right here. And this should lock these plates from moving. Okay, so now that we have this plate locked into place, we're going to just go ahead and align this channel up here, and then we're going to copy it, Control-C, Control-V, and then we are going to put this on the other side. We're actually going to flip this channel just so these little flanges are facing the inside. And we don't have to coincidentate this face to that face because this part already can't move anyway, so there's really no point. Okay, so we're gonna get this front face, and then we're going to get this face as well, and then we're gonna select parallel. And now what we're gonna do is we're going to go down to, in this mate tab, we're going to right click our parallel mate and click flip mate alignment. And there we go. Now these flanges are facing the inside. Now we're just going to line these two channels up by getting the roof faces of these two channels and then coincidenting them together. And then we'll just pull this back there. Oops, that's not what I want to select. There we go. Okay, so now we have our channels. We need to get our angle brackets now. So you're going to go to Insert Components, then angle bracket. We'll place this down. And we're going to need 1, 2, 3, 4, 5, 6, 8 of these. 2 for each corner. We're just going to paste that 7 more times. It's going to take a bit to load. There we go. So we're going to get this face of the angle bracket, and then this face back here, and then we're going to coincident these together. Okay, so now we're going to align these holes up. Let's get this hole, and then we'll select, make sure you select exactly this hole right here. And then we're gonna get this hole right here of the angle bracket, and then get this hole on the channel. Looks like our U channel slid out, not slided. Whoop. Okay, let's just bring this back down. Okay, so we have one bracket on. We're just gonna do this for each corner. So we're gonna get this face again. Or actually what we can do is we can delete these, and then we're just going to copy paste this one over here so that they're in the correct orientation. If you want to mass delete something, you can just hold down and use your box select, and then that'll highlight all of these, and then click delete, and it's gone. Okay, so we're going to get this angle bracket. We're going to copy this, and then we're going to get this hole on the angle bracket and align it with this hole on the channel. We're going to drag this out so it's easier to access the holes. We're going to get this hole, line that up, and then finally we're going to attach these two faces. There we go. Okay, so now we're going to do them for the other corners. Control V again, get this face, that face, find the mate you just did, flip the main alignment. Then we are going to, oh, wrong face. We're going to make these two faces together, the angle bracket and the channel. And then we're going to flip that main alignment as well. Okay, now we're going to get this hole and this hole and connect them. Since we already coincidented the inside of this face to this plate, we don't have to do the second concentric because it's already parallel to the bottom plane anyways. So now we're going to select this, copy it, paste it. Make sure when you're copying and pasting you're selecting the entire part, or else it might give you an error, something along the lines of this item from the clipboard could not be copied and pasted. That's because you're just getting a feature from the part as opposed to the actual part. And features, I'm pretty sure, can't be copy pasted in Solidworks. So yeah, make sure you're copying the entire part. Now you're going to go to the back, get this hole, line them up. Cool. I'm going to go to this side, paste again. I'm going to get this face and get this face, coincident them. Now we're going to flip this main alignment again. I'm flipping a lot of mates this tutorial. Now we're going to get this face and the drive plate and connect these together. And it looks like this misaligned, so it's on the outside, so we're going to yet again flip this main alignment. There we go. And then finally we're going to concentric this in. This part of the tutorial is fairly repetitive, but once you get like one or two down, you can quickly just run through them all. There we go. Get this hole, get this hole, line this up. Okay, last corner. I'm going to paste. Attach these faces together. Flip main alignment. Oh, oops. Sometimes if you scroll too far down, it will send your cursor all the way to the top. It's a bit annoying. Now you're going to get this face and this channel and mate those together. And as you can see, misaligned, so we need to flip the alignment yet again. Get this hole, get that hole, and then concentric. Yet again, copy paste this so it's in the correct orientation, and then do the same thing you just did. Oh, oops, looks like my Solidworks is bugging out. There we go. Get the right face here. Finally, we're done with all of these. So now that we have these in place, we're going to line these up and make some holes in the plate for them to mount onto. So we're going to want to make sure we don't get too close to this hole right here, because the screw will go there and then you're going to collide with your channel and that won't be good. So we can keep this. Or wait, what we can actually do is we can employ a distance mate to center the channel in the center of the drive plate, and what that will do is that will hold it in place so that when we do our holes we can get them in the proper place, and then delete that distance mate so that everything's nice and secure. So we're going to get a measurement, go to evaluate, measure, get the bottom of this channel. Oh, it looks like I already selected something. When you have something selected and then you click the ruler, it's automatically going to clip to that, so make sure you have nothing selected when you click the measurement tab. We're going to get both the top and the bottom of this channel, and then we'll see it's 48 millimeters, and we made the this drive plate 80 millimeters tall. So what we're going to do is we're going to open, we're going to calculate 80 minus 45, or 48, so that's 32, and 32 divided by 2 is 16. So that means we're going to offset the top of this channel from the top of this drive plate by 16 inches, or 16 millimeters, sorry. There we go. So now this channel is perfectly centered, and then we're going to delete this mate later once we have our holes in. Now we're going to move this closer. We want to get it as close as we can to the motor. That way we have a lot of room here and here, while still not like impeding on the screw that's going to go here. So I think about here should be okay. We're going to get this face and get this face, and then distance make this as well. Just get everything in place so that once we are in position to do our holes, we can get the holes really nice and accurate. So we're going to change this to, right now it's like 7.154 and it repeats, so we're just going to simplify this down to 7.15. That's good. And now we're going to get this face and this face. Distance. That's 4.49, so we're just going to round this up to 4.5. So, to recap, these channels should be 16 millimeters away from the top of the drive plate. This one should be 4.5 inches away from the back of this drive plate, and this one about 7.15 inches from the front of the drive plate. Make sure you have these in the right position so that you can so that the holes that you make will be accurate to the ones I'm about to make. Okay, so now we're going to right click this drive plate, click edit sketch, and there we can see all these holes. I'm just going to hide this outer drive plate by clicking tab. There we go. So now I'm going to get out my circle tool, line this up, and then once again 2 millimeters. Go to holes are 4 millimeters in diameter, which means 2 millimeters in radius, and Solidworks takes radius measurements, so we input 2 millimeters. Line it up with the crosshairs. Okay, that's that side. Now we're going to get the other side. Sometimes it's a bit tricky, you have to realign. There we go. Especially with this mechanism in the way, making holes can be a bit tricky. Another way to do it is to, instead of like editing the sketch, like inside the context of this assembly, I'm just gonna hide this mechanism right here. So we're gonna go out of here. I'm gonna click Exit Sketch. Okay, so before we do the rest of the holes, we're going to click on this pulley, and then click on the left mechanism assembly, and over here we'll click Hide Components. Okay, there we go. Now we're going to right click, Edit Sketch, get the circle, drag this out 2 millimeters, drag this out 2 millimeters. Okay, so these holes are in. We're going to unhide this left mechanism assembly, and then unhide the drive plate. Where is the drive plate? Here it is. So now we're going to delete those distance mates, just because in my experience, distance mates cause a lot of trouble when you're once you have like large assemblies. So we're just going to delete all those distance mates, and then we're going to just drag this away, and then we're going to get the hole right here, and then concentric mate it to the holes we just created. There we go. And then we'll probably need, we'll need another one. Kind of have to line it up a bit so you can look through it properly. There we go. We'll get this edge, this hole, there, concentric. So now this channel is completely fixed. Now we have to take care of this one. Well, it looks like we still have a distance mate. Or, oh wait, no, this is just coincidentate to this one, so it's fine. We're going to drag this out. My Solidworks is kind of lagging because I have the screen recording software and the webcam going at the same time, so it's running a lot slower than it should be. There we go. Now let's get our second one. Gonna move, oh wait, no. Since this is already, the top of this channel is already coincidented to this one, this channel is parallel, and then you won't need a second or concentric. It's kind of the same situation we had with this angle bracket where we already mated it to the drive plate, which makes it parallel, so you don't need a second concentric, which is saves some time. Okay, so now we just need to replicate this onto the other side. You could do something called a mirror, but in my experience, mirrors kind of mess up a lot. I don't know if I'm bad at mirrors or just it's an issue with SolidWorks. It's probably just an issue with my skill level, but I prefer just to recreate it manually. So we're just going to get this motor plate, copy this. I'm gonna run through this much quicker than I did before. Concentric this. Concentric this. We're just getting all the framework into position. Gonna get this outer drive plate. Copy this, paste it in, and you can really start to see the drivetrain coming together. Get this hole. Get this hole, concentric. The thing about this kind of drivetrain is that it's really flexible to whatever you need, because it's pretty low profile. So if you need a lift or you need an intake or anything like that, it's pretty easy to add on to it. You can just make a new hole and then just rearrange everything. And it's pretty easy to build on top of as well. We have like the go-to mounting pattern over here, so if you want, you can just like attach a Lexian. What our team does is we take a sheet of polycarbonate or Lexian and like put it on attach it to the floor of the robot, and that just makes it easy for like wires and electronics, we can just tape all the, or zip tie all the wires down there, and that just keeps the wires out of sight, out of mind. I'm gonna coincident this, and I'm just gonna copy this and spam it wherever we need it. Drag this out so we can see this face. Click on it, click on this, or not concentric, coincident. This is going to be concentric as well. Oh wait, no, not this one. Over here. You can also add like more support beams like this 12mm shaft right here around inside this drive pod if you see fit, just to make sure everything's really tight and robust. You just make a new hole wherever there's space and just fit one of these in there. However, I recommend keeping this space right here between this motor and the wheel, open for your odometry to go in. And we might talk about odometry later in this series. Either that, or we'll make a programming tutorial series, and we'll talk about it there. Okay, we have all of our support beams in. Okay, so this is something you need to pay attention to. Make sure your mechanism wheels are facing in like an X formation, which means these rollers are facing outwards, these rollers are facing outwards, these rollers will face outwards, and these rollers will face outwards. Otherwise, your robot will struggle to strafe and move. So this pay as much attention as possible to your orientation of your mechanism wheels. We're going to get this right mechanism assembly, we're going to copy it, and we're going to paste it over here. And then this mechanism is going to go down here onto this shaft, the bottom left. We're going to concentric mate onto the shaft. And as you can see, this pulley is facing the inside when it should be facing on the outside. So we're going to flip this mate alignment. But before doing that, what we can do is go over here, get this spacer that's between the pulley and the drive plate. And what we can do here is, instead of just parallel mating it and then flipping that mate alignment, we can flip the mate alignment on the spacer, and that'll be a bit more productive because we can kill two birds with one stone. You can get the spacer done, and we can flip this mate alignment. Yeah, so concentric mate this onto there, and then get a face and line the face up with the shaft. And then you're going to coincident mate the spacer onto the plate. Now we're going to get the outside, make sure you get this face right here, the outside face of the pulley and the inside face of the spacer, and then coincident mate them together. And now we're going to flip this mate alignment. Hopefully this works out okay. There we go. So as you can see, oh, don't show, you can check. Don't show this again in the session, click no. As you can see, these rollers are facing in the correct direction because they're going outwards. It's creating an X. All we need is the third wheel right here. Let's just, before we bring this mechanism over, we'll paste this spacer in. Concentric made this onto the shaft. And then get the space, line it up. And then attach this to the inner plate, or the outer plate, I guess. Okay, so now you're going to fetch your left mechanism assembly, copy this, and just paste it over here. You're going to select this inside bearing hole and select one of the fillets that's placed on the shaft. And since the fillets all orbit around like the center of the shaft, when you concentric mate it to one of the fillets, it will basically make the same effect as if you selected the inner circle that runs through the shaft. We're going to get this bearing face. We're going to attach this over here. and then we're going to flip this mate alignment. There we go. Okay, so now we have our mechanisms in formation. We can see they're facing an X, that's good. Now we're just going to get our spacers, our inside spacers in here. Okay, we have it here. We're going to orbit until we can find this face, then orbit until we can find the bearing face, and then just coincident these. And then we're going to do this one last time for the back mechanism wheel. Paste, concentric, pull this out, get the face, get this face, and then there, coincident. Okay, now that we have our wheels done, as you can see they're forming a cross formation, we are going to get this little motor assembly right here finished. We're going to get this standoff, copy it, paste it. Then we're going to concentric mate this to any one of these holes. So I'm going to select the center top hole. Just looks the most appealing to me. I don't know. Personal preference. You're going to get the inside of this motor plate, the back end of the standoff, and the inside of the drive plate. Oh, oops. Instead of, now we're going to go back to this coincident mate we made, where the standoff was connected to this motor plate. We're going to actually delete this because we need to, if you remember from the last episode, we need to put a spacer in between. We'll get the spacer from over here. Copy this. Run over here. I'm going to concentric mate this standoff and the spacer. Pull this motor plate out. Pull the spacer out to a point where you can see both of the faces. Get the inside of the spacer, or actually get this side of the spacer and get the outside of the standoff and connect them together. And since we do this, we can copy paste the standoff and the spacer, and they will remain mated when we paste this. So we're going to paste this 5 more times. 1, 2, 3, 4, 5. Hopefully we won't have to delete them this time, like we had to do with the angle brackets. Well, this is loading. Okay, we have our standoffs. Yeah, they end up in weird places. I don't know if it will end up there for you, but I guess maybe it's just for me. I don't know. But just zoom out a lot and you'll find them, and then just bring them back down. Okay, now you're going to get this face and mate it to this face. And then get this face back here and mate it to the inside of the drive plate. Now get this this hole, and then get where did our standoffs go? That's weird. Oh, they're all the way over here. That's embarrassing. Okay, we'll get the outside of the standoff. Go back here and get this hole and concentric. At least I know where they all are now. Get the inside face of this and get the inside face of the plate. And then repeat. Over here, get this standoff. Well, I guess it put us in this place. So while we're here, we're going to get this standoff as well. So like this final standoff, and then bring it over here. Get this last hole, concentric it. Then we're going to coincident these faces. Going to coincident the other faces. Oh, not that. This one. Alright, so now we have our structure in. We just need to put the motors in. So let's just go grab this motor. I'm going to copy the entire motor, paste it. We're going to get this face, this motor face, and then get the motor plate. Scroll down until you can see your mates. Find that coincident mate and flip the mate alignment. Once you're here, we can you can either just get this outside and then concentric mate it to that hole right there, or you can line up the screw holes yourself. But for the sake of time, I'll just get the outside hole. Then I'll copy paste this motor that we just made, and then concentric these again. And then we have to mate this face to the motor plate. There we go. And then we'll get these bearings in as well. These bearings over here. Select a face, copy it, gonna go paste it. Align these faces. Once again, flip the mate alignment. A lot of stuff are going to be misaligned when we transfer the right stuff over to the left stuff. Or the right side. I should stop saying stuff. And then we're going to get this bearing again. Paste it over here. Concentric these holes. Oh, oops, I messed up. I did not mean to do that. I accidentally hit this, but I'm just going to hit it again. There we go. That's fine. And then we'll get this hole, like we meant to do. And then get the inside face here. And fit it onto the plate. Okay, now we need to go get the pulleys. We have to get the pulley and the sonic hub. So we're going to select this face, find where it is on the feature tree, click the part again to make sure the entire thing's selected, and then find the sonic hub, this right here. Make sure, yep, it's the right sonic hub. And then paste this over here. Oh, and yep, it's gonna end up over there. It does. I'm just gonna grab this face, pull it down. Hopefully I'm just. Oh. Okay. Probably the smarter thing to do would be to concentric this face onto the shaft, but I guess that didn't cross my mind right there. Whatever. Pulleys all the way over here. I have no idea why it does this. Solidworks is weird. Okay, so we have the sonic hub's facing the inside right now, and we need it to be facing the outside. So we're just going to go over here and get the spacer we made. Copy this, the motor spacer. Scroll over here. And something you can do, if your SolidWorks is running a bit slow like mine is, click on Assembly and click on Large Assembly Mode. As you can see, the graphics are a little worse, or not a little, a lot. But what you can do is you can click on this box right here, and then click on this top thing, and there. So it looks a little better and it runs a little better as well. And that's called a large assembly mode once again. Okay, so now we're going to paste the spacer in, concentric this onto the shaft, get the space, align it with this face. Okay, now that we have it here, what we're going to do is we're going to temporarily fix this in place, and I'll explain later. We're going to end up unfixing it later because we shouldn't be fixing things, but in this case we have to. So we're going to mate this sonic hub to the spacer, and then we're going to flip this mate alignment. Yep, so our sonic hub's facing on the outside. Now we're going to click on the spacer, right click, float. So the reason we fixed that in place last time is because this is a very peculiar case where we have three different parts that are working together: the pulley, the sonic hub, and the spacer. And when we try to flip that mate alignment, it'll end up wonking out, and the pulley will kind of merge into the plate, which is not what we want. So if we ground this space in open air, it will kind of, instead of working with three movable parts, we're working with two movable parts, which is a lot more rigid. So yeah, make sure you set that to float later once you're done. Okay, now we're going to select this pulley and select the sonic hub. Copy it and then paste it right here. We're going to concentric the pulley onto this motor shaft. Yep, it's all the way here once again. We're going to zoom more in. Get this face, or not this face. Get this face, concentric. I'm going to get this sonic hub face, and then... Oh, actually we need to get our spacer in here as well. We're going to get this spacer, copy, paste. Get the interior of the spacer and get the exterior of the motor shaft, and then mate the outside of the spacer onto the bearing. Okay, now we're going to select this side of the bearing and then the sonic hub, and then mate those two together. And there we go. Let me just check to see everything's here. Yeah, so that's the basics of our drivetrain right here. Later we will add belts onto these pulleys just to make it more realistic for the renders, but they're not really a necessity unless you want to see how the belt will interact with like the other parts, or just make it look nice for pictures. So yeah, that's our drivetrain.